Hi, this is Mr. Max with Sankofa Mathematics. So I have got three questions lined up here today, and it's about trigonometry and sketching of graphs and answering questions like solving equations and also uh, writing expressions in inverse form and also stating things like the domain and the range of the inverse of a function. Right, so this is question one, and you can see that this is a function that is defined by f such that x is mapped onto 4 sine x minus 1 for the given domain of minus half pi radians to pi radians. Then the first question asks you here, or the first instruction is supposed to state the range of the function. Part B, find the coordinates of the points at which the curve of y equals f of x intersects with the axis, that means where it intersects with the x-axis as well as the y-axis. Then you're supposed to sketch the graph. So normally, before I sketch a graph, I like to put all the values, the minimum value, the maximum value, the center line, all right? It should also help for you to know where the function starts. Since this is a sine function, normally sine function will start at 0. So here now it will start at -1, okay? Or if I have to look at it another way, is you are going to add 4 plus -1. You're going to see that we're going to talk about the center line. It's going to be quite helpful to do that as well. Then we're supposed to obtain an expression for the inverse of x, and then we're supposed to state both the domain and the range of that inverse. When you are stating the domain and the range of an inverse of a function, you should remember from functions that the domain of an inverse of a function is equal to the range of a function. And the range of the inverse of a function is equal to the domain of the function. It might seem a bit confusing, but I have put it up nicely when you see that part of the slide. Right, so for part A, we definitely have to find, you remember the graph of y equals to a sine x plus c. Your value of a, that amplitude is 4. It is your a value, your c value is -1, as you can see here. Then the maximum value is you're going to add 4 plus that -1, you get 3. And the minimum value, you're going to put a -9 in front of that a, and then you add with that -1 giving you -5. So the range would be from -5 to 3. The coordinates. So first of all, as I said, I like to draw the center line. Now in this particular case, the center line, you can quite easily see it because it's just from the function y equals to 4 sine x minus 1. So that -1 will be where the center line is. Also, it will be where the y-intercept is because it's going to go down by that much from the y-axis. So that -1 that you see in the function here, that is the vertical translation of the sine curve. And the coordinate, therefore, because we're supposed to find the coordinate of the y-intercept will be 0, -1. And if you want to find the coordinate of the x-intercept, you got to take that function, let it equal to 0 for y, and then you got to solve that equation. Now you know that sine of x is equal to 1/4. Make sure that when your domain is given in radians, that your calculator is in radian mode because the angle we're going to look for should be in radians. And as you can see, it's 0.253 radians, and therefore the domain or the coordinate of the x-intercept is going to be 0.25 radians, 0. So these are quite helpful when you are going to do part B. I mean the part C where you are supposed to sketch the graph. Right, so with sketching, it's quite a little bit tricky, okay? But you can use a calculator and then you can also have your intervals, right? You will see that my sketch is from minus pi half to pi over 2, and sometimes it will be helpful when you are doing this because you're not going to get a grid, something like this. It's just going to be a blank page. So it'll probably be helpful if you can put in other intervals here, like for example pi upon 4 here and negative pi upon 4 here. Okay, and then you plug them into your function, and then you see what your output would be, and then you plot those points more or less where they would be, and then you can draw yourself a curve, something like that. Remember I said the y-intercept is going to be at -1, and the maximum value was 3, and the minimum was -5, as was seen from our range. Also, when you look at this particular function, the domain is from minus half pi radians to half pi radians. The range is, as I indicated from before, between, now the range is your x, your y values. The ranges go from -5 all the way up to 3. So when you are writing down the domain and the range of your function, then it's easier for you to answer part D, where they ask you to state the domain and the range of the inverse, because you would realize that, for example, the domain of the inverse is going to be exactly the range, just put with an x, and the range of the inverse is going to be like the domain, and then you just put a y there. Okay, so we're going to have to first obtain an expression for the inverse. So write that as y equals to 4 sine x minus 1. Swap the letters around. The objective here is to make y the subject of the formula. But remember, you're not dividing here by sine y. You need to get rid of that sign by taking the inverse. All right? Arc sine of x plus 1 upon 4. And now you can rewrite that with the correct notation. So the domain of the inverse is going to equal to the range of the function. So you can see the range of the function, and I'm just going to put an x there. And the range of the inverse is equal to the domain of the function, and I put a y there, and you can see the similarity. If you have them like that, you remember them like that for all functions, you will not have a problem. Question 2, again, you can pause the video, write the question down, and then you can attempt to solve the question. It says that the function is defined by f such that x maps onto 5 minus 2 sine 2x. For x between 0 to pi radians, then you're supposed to state the range of the function, sketch the graph of y equals f of x, then you're supposed to solve the equation f of x equals to 6, but you must give your answer in terms of pi radians or in terms of pi, so you must make sure your calculator is again set in pi radians, and I hope you still also remember special angles from videos that I've done before. And there's another part then to the question where they are giving you the function g is defined by g such that x is mapped onto 5 minus 2 sine 2x for x between 0 and k, where k is a constant. So you're supposed to find the largest value of k for which g has an inverse. And this one is quite interesting because you can only do this one if you have the sketch from part B, because once you have that sketch, from your sketch you will do what we call horizontal line tests, and those horizontal line tests will determine whether the inverse will be having a one-to-one function or a many-to-one function. And remember, the inverse, it needs to be a one-to-one function, so you will have to see where you can draw your line until you can find that particular constant. And then for that particular constant, then you're supposed to find an expression for the inverse of g. Okay, so let's get down to it. So the first part is similar like what I did in the first question. So you can identify the maximum value by taking minus 2 plus 5, which gives you 3. And the minimum value is, put a minus in front of that, that gives you 7. But this is not quite correct, because this 7 here is going to be the maximum, and the 3 will be the minimum, because the graph is a reflection, okay? So normally the sine graph, but the minus in front of that sine stuff tells you that the graph will be a reflection. So the minimum value is 3 and the maximum value will be 7. So therefore the range is going to be from between 3 and 7. Always the small number on the left, the big number on the right. Remember that. Right, so before I sketch, I just want to bring in some other few interesting stuff. Where would this graph, if I had to sketch it, because they don't really particularly say you must find the x-intercept, but I have calculated, but only until a point where you realize that there won't be an x-intercept. Okay. Also, when you do the center line, that 5 there indicates that that's the minimum, that's the center line, and the minimum value is 3, so it doesn't go below 0, so therefore it cannot cut the y-axis, or the x-axis rather. But it's also nice to know. So the y-intercept, as we say, you can actually see that from your function, which is that. So the y-intercept is that 5 as indicated. Okay, so I hope you have given it a go. The graph should look something like this, starting at 5. Okay, you see that? And then it goes down, goes up again, and to pi radians. And that 2x tells you the period should be between pi radians, that is 2 pi divided by 2. That gives you pi. So you should have the picture of a sine curve as you get it. It should be a complete picture between this interval here. Okay. Then you were supposed to solve the equation when f of x is equal to 6. So you take the function, let it equal to 6. So try to make sine 2x the subject of the formula, so to speak. Move everything over, so I get to negative a half. But that is 2x, so it's always better maybe to write it as a k. And also something worth noting is that that 2x is going to affect your domain. So your domain should now be multiplied by the 2. Okay, so your new domain is going to be something like this here. And now I am taking k, but remember later on I'm going to replace my 2x because I'm letting k equals to 2x. So the basic acute angle, remember you make these a positive and your calculator should be in radian mode, will be pi upon 6. You can also remember that from special angles, but you can use your calculator anyway. So this is the particular angle that is our reference angle or basic acute angle. And when you look at this ratio here, you have a negative ratio, and sine is negative in the third quadrant as well as in the fourth quadrant. So that is why I don't consider the first two on top. So if you were calculating the third quadrant, then you have to take 180 degrees or pi radians plus that k and 2 pi minus k in the fourth quadrant. Okay, but I'm not dealing with k, I'm dealing with 2x. So I'm going to have pi plus pi upon 6, which was my reference angle here. And solving the other side, going to be 2x equals to 360 degrees or 2 pi radians minus pi upon 6. Alright, I still hope that you remember pi upon 6 is nothing but 30 degrees. And you go ahead and solve this one, gives you x equals to 7/12 pi, or x equals to 11 pi upon 12. That is about 11 o'clock is 300 and about 330 degrees. Give or take. 330 degrees is 360 minus 30, that's 330 divided by 2. Okay. So close to 100, and remember I said 330 divided by 2, that's about 165 degrees. Anyway, the answer should be given in radians. Right, that other part where they say the function is defined and where k is a constant, and they want you to find the largest value of k for which that g would have an inverse. So let me just bring back that graph again. And I have a little story here. Then I'm saying you're going to use that graph and then you're going to do a horizontal line test. The line must cut only once, okay? So for example, if I was drawing that line here, you see that it will cut the function at 2 places here in the given domain. If I do it here again at 2 places here, so I need it to cut only once, and you realize it has to be that particular line here. So whatever this particular angle will be, that will be our k, that will be our constant, okay? And that constant is pi upon 4. Okay, pi upon 4 is like 45 degrees. So that is the value of k that we are working with. So part E, for that value, you're supposed to find the inverse. Again, let y equals to 5 minus 2x sine 2x. Change the letters around. The objective here is to make y the subject of the formula. So it's just your algebra should be sound. And I hope you don't get confused. When I have x minus 5 divided by minus 2, and that minus 2 comes on top, it's going to be a negative times a negative 5, making that 5 positive and the x negative. So this statement here, 5 minus x upon 2, is exactly identical to x minus 5 upon negative 2. I just didn't want the negative 2 here. So it's like I'm taking that negative 2, put it up here, and then I distribute it over in the numerator. Right. So then you take the inverse of that, but now you have got a 2 here and y should be alone. So naturally you divide both sides by a half or by 2. Dividing by 2 is the same as multiplying by 1/2. And your function should be, the inverse function should be 1/2 sine, inverse sine or arc sine of 5 minus x upon 2. Right, so we have the third part or the next part of the question, question 3. It's going to be divided into two parts. So you have got a function here, f of x is equal to 3 minus 4 cos of kx in that domain from 0 to pi radians or 0 degrees to 180 degrees. So again, if there's an equation involved, as you see, it's better that you change your calculator display. It should be in radians. Alright, so go ahead then and let's try to have cos square x on its own. So you should arrive at cos square x is equal to a half. So this is like something squared. So to get rid of that square root, the square, you need to take the square root, and the square root will be a positive and negative, okay? So there are two possibilities that you're going to deal with. You're going to find where x is positive and where x is negative. But first, we probably won't want to know what the basic acute angle is or the reference angle. But you should also take note of your domain, okay? So again, from special angles, you should realize that cos of pi upon 4 is equal to 1 over root 2. So my reference angle is going to be nothing but 45 degrees or half or pi upon 4 radians. Again, we're going to consider the cosine when it's positive in the first quadrant. So one of the solutions is going to be pi upon 4 or 45 degrees, and the second solution will be pi minus the angle of pi upon 4 or 180 minus 45, which is 135. So my two solutions therefore is x equals to pi upon 4 or x equals to 3/4 of pi. Right, then second part says the function f is such that k is a constant. Now they are saying k should equal to 1. Now you're supposed to find the range of that function. So finding the range is very easy, right? Remember, range is going to be that maximum value first that you have to calculate and the minimum value. Alright, again you can see because there's a minus 4 in front of the cosine, it's going to be reflection, so the minimum value is -1 and the maximum value will be 7. Therefore the range is between -1 and 7. The second part you're supposed now to sketch, but before I sketch I always like to work with the center line, but at 3 tells me, but remember this is the cosine, and cosine starts at normal cosine function, they start at 1. So it's going to start at the minimum value of -1. So I just use that center line when I do sketch it to know exactly how high up and how low down I should go. Okay? And then where does it cut the x-axis? Well, it will cut the x-axis at 0.723 radians. You can calculate that out. Calculator must be in radian mode. I like to do that as well so that I can have a general idea, especially if you want to know how far it should be away from half pi radians. Half pi radians is about 1.5 radians if you write it as a decimal. Okay, so my graph looks something like this. So this particular point here, it's not really required, is at 0.723 radians. Okay, and pi upon 2 is like 1.5 radians approximately. Okay, so this is the part of the graph that you're supposed to draw. And remember I said it starts from -1 because the cosine function start normally from 1, but this is also a reflection, so it will start at the minimum value and then all the way up to -7. Right, so they are asking us to state with a reason, or they want you to state whether this f has an inverse. Well, if you remember from the previous video or previous slide that you had to sort of draw horizontal lines, you'd realize that if I do the same here, it's just going to cut this blue function between these 2 points. Is going to cut it only once. So therefore it has a inverse, and it will be a one-to-one function, the inverse of such, if you were to draw it, but the question just wants you to state.